Hey, college trig kids. Here's our, whoops, should say four, whoops, again, fourth online lesson for college trig. This one's going to seem incredibly basic compared to what we've done for the last 2 months, even leading up to the lockdown of identities and all that fun stuff, because this is day one of our last unit, which is very numerical. Pretty much everything has number answers, and you don't really have to care about your trig sheet and stuff like that. Unit 4 is now over. Not really going to have a test because not sure how to do that with remote learning. So we're going to call it good and move on. Um, so half of this unit is about solving triangles. We've done a lot of that with right triangles, so we're going to do a review today on that. And then the other chunk is based on non-right triangles, so we have some new formulas to learn then. So this first one's going to seem pretty basic, should be very familiar, very straightforward. So first of all, don't forget your equations, your easiest stuff you learned in geometry. Okay, Pythagorean theorem and the triangle sum theorem. So the triangle sum theorem is the technical word for saying that the three angles add up to 180. Don't forget that. That can really make a lot of problems basic. All right, just if you have two angles and you find the third, there you go. And that works even if it's not a right triangle. So that'll show up in a lot trickier ones. Just remember that. And then the Pythagorean theorem, a squared plus b squared equals c squared. Okay, also very basic, but the biggest issue people usually wind up with is forgetting that the c has to be the hypotenuse. So just a reminder how we label our triangles. So let's see if this is A, B, and C, then these are little a, little b, little c. So capital means the angles, lowercase means the sides. So just don't forget that. All right. SOHCAHTOA is also in here. So if you cannot use Pythagorean theorem, SOHCAHTOA. Okay, the bread and butter of trig. Now, SOHCAHTOA comes from S-O-H. Whoa, I have a typo. Cosine AH, so CAH, and tangent OA. SOHCAHTOA. I'll make sure to fix that typo before I upload the notes themselves, but this video, there's going to be the typo. But I fixed it. So don't forget you have these formulas that you can use on any of these triangles as well. Okay, so let's try some examples going through each of these, and really that's it for the right triangle trig. And then we'll go on to non-right triangle trig starting next week. So let's do the easier ones first. Find the indicated missing information. Depending on what you have and what you need determines what you should use. In this triangle on the left, I've got two angles. I want the third. That's a pretty clear-cut case of the triangle sum theorem. So if I take 180, subtract the other ones, handy dandy calculator, 50 minus 45. All right, sorry, probably keeps on seeming like it's cutting out to you. I am overtaxing my computer right now trying to process a video and record a new one. So if it cuts out again, I'll probably just scrap it and start over. So if you have two angles, you're finding a third, triangle sum theorem, subtract from 180, and that's all you need to do. If you have two sides and you're trying to find the third, that is an indication that you should use Pythagorean theorem, but use it carefully. If the 7 is our A, the X is our B, the 16 is our C. Okay, remember C is always the opposite of the right angle, so set it up like 7 squared plus X squared equals 16 squared, not 7 squared plus 16 squared equals X squared. That would be bad. That gets you the wrong answer. So let's see, 7 squared is 49, 16 squared is 256. Subtract, I get X squared equals, let's see, 256 minus 49 is 207. And then square root of 207. Let me check my calculator. 14.38749, blah, blah, blah. So I'm going to say 14.4 and feet. So round to the nearest tenth. I think that's what the Schoology quiz says. And you should be good there. So if you have two angles, you need to find a third. Triangle sum theorem. If you have two sides, you need to find a third. Pythagorean theorem. Okay. The trickier ones come in when you have to use SOHCAHTOA, so let's check it out. So if we're solving for x and we don't have two angles, we don't have two sides, this is going to be a SOHCAHTOA. So here's where we need to be careful with labeling our triangle. I am given the angle 57 degrees. I'm going to call that my reference angle. The hypotenuse is always the hypotenuse. The opposite of the angle is my opposite. The one touching it is my adjacent. Okay, so if we look at this, we don't even care about the adjacent at all. So in SOHCAHTOA, adjacent is the A, so I don't want the tangent, I don't want the cosine. All I want is sine. Okay, so sine 57, opposite is x, and 19. So to solve for x, multiply both sides by 19 to cancel, and my answer is whatever 19 times sine 57 is. So with my calculator in degree mode, I'm going to type that in, and I get 15.9347, so 15.9. So first step, label the triangle, figure out which stuff you need. Use only those trig functions, okay? Don't use a trig function you don't need. If I were to try and set up cosine would be adjacent, which I don't even have a number or a letter for, over hypotenuse, so I don't even care about the adjacent. That's not going to solve for x at all. X isn't even a part of that. If I try to set up tangent, I don't have a number for adjacent, so I can't solve for it. So make sure you're only setting up the trig function that you can solve. Okay. So if we're finding an angle, it's kind of the same thing as finding a side. In this case, I have two sides. I could use Pythagorean theorem, but that would find something I don't care about. So I don't want to do that. So I'm going to label, the question mark will be my reference. Hypotenuse is always a hypotenuse, opposite, adjacent. So in this case, we don't care about the opposite. So in SOHCAHTOA, that's the tangent and the sine. So I'm left with ka. So cosine of my question mark equals adjacent over hypotenuse. And we've done this stuff before. When you're solving for an angle, you need to do the inverse. Cosine 29 over 34. Make sure you know how to do that on your calculator. For the graphing calculators, you press second and then the trig function. So I'm going to do that. If you're using your phone calculator, I'm sure you can figure it out. Let me know, and I should be able to help. Is 31.46697629. So but again, so second. So 31 degrees. If you're only solving for one side, one angle, that's all you really out of the place. Again. All right. So slide says solve the triangle. You got to find everything that's missing. Okay. You will pretty much always be given 3p3. The triangle has three sides, three, you have three left. So I'm going to label this triangle every a y or a z. Now, depending on the order you go, this could be relatively easy, relatively difficult. To find my, hopefully, you know how I can figure it out so quickly that it is 32 degrees. Degrees because triangle sum theorem degrees. So now I need the x and the z. So for those, I've got a side, I've got angle. I'm going to use the 58 as Z is my hypotenuse. It's really lagging on me. Catch up. All right, I think my computer's done trying to crash on me. I just resumed it for a second. Sorry that it keeps on cutting out. Hopefully the audio is fine. I'll try to not overexert my computer next time. So if A is my reference, Z is my hypotenuse, let me get my pen back. That means 15 is my opposite, X is my adjacent. Now, in this case, I care about the adjacent, the hypotenuse, and the opposite, just not adjacent and hypotenuse at the same time. So if we think SOHCAHTOA, cosine adjacent hypotenuse both at the same time is going to be a bad time because let's say cosine 58 equals adjacent over hypotenuse, x over z. That's not solvable, okay? You can't have two variables in an equation to solve it. So we don't want cosine, we want sine. So sine 58 is 15 over z. And tangent. Tangent 58 is 15 over x. Now, when the variable's on the bottom, the trick is to just swap it with the other side. So for the sine, z equals 15 over sine 58. For the tangent, x equals 15 over tangent 58. And throw those into my calculator. 15 divided by sine 58 is 17.687, blah, blah, blah. So let's go 17.7. And 15 over tangent 58, 9.373, blah, 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 so 9.4. So now a good practice to do, write these in your triangle, make sure the numbers make sense. So if you look at this, the hypotenuse needs to be the longest side, which 17.7 is the longest side. The other sides are going to be smaller, 9.4, 15, those are both smaller. So it's a good indication that we're good. And that's what solving a triangle is. Got to solve for everything that's missing. You have three sides, three angles. You're going to have to solve for three things most likely. So that's it for the review of the solving right triangles. Hope that helps. Next week we'll go into solving non-right triangles, spend a couple weeks on that, and then a little bit more, and then we're done. Just a reminder that even though your Cherokee Trail grades cannot go down, your CCA grades can, and you need that C or higher to get the college credit. Please reach out to me if you have questions or concerns on that. Essentially, if you're at like, I'd say a B minus or lower, you might be at risk of dropping below a C. Each lesson is like a % of your overall grade. So we got like 12 of these lessons to go through, I think. So if you think about your grade, minus 12, do you still have a C or higher? Just think about that. And let me know if you have questions, concerns, and let me know if anything else will help, if you want any extra examples, practice, whatever. And hope you guys are staying safe, staying healthy, and I'll see you on the other side.